Welcome to episode 10 of Renewing the Conversation, a series of interviews where we talk to leading industry professionals and experts about renewable energy and heating with a focus on the home and what challenges face the industry and homeowners.
Today, welcome Dr. Jason Cassells, Managing Director at Renewable Energy Devices, or aka RED. Jason tells us what makes RED heat pumps unique, why they adopt a holistic approach to heating design, and what the future is for heat pumps.
Before we get started, we would like to say a huge thank you to today's sponsor, Freedom Heat Pumps, the UK's #1 heat pump distributor that turned heat pumps into great heat pumps. To find out more about Freedom Heat Pumps, please head over to their website, www.freedomhp.co.uk. The link's in the description below.
And don't forget to hit the subscribe button below, and please show us your support by giving us a thumbs up. We hope you enjoy the interview. Thank you so much for joining us this morning, Jason. It is an absolute pleasure and a bit of an honor to have you on our show.
Wow, an honor. That's very grand. Yeah, okay.
We recently interviewed Graham Hendra. In his words, he said that the RED heat pumps are the most advanced on the market and there is a lot under the bonnet.
Yes, well, very flattering. Thank you. Thank you, Graham. Yeah, okay. Great.
So can you tell us what is it that's under the bonnet that makes the RED heat pump so impressive?
It's probably very hard considering you don't really like bragging about your own things. Maybe that's my nature. But if I tell you some of the problems that I had to solve when I developed the heat pump. So yes, it's a heat pump, but I think of it all as a heating device and a heating system. And that's how I've approached these things. So it's not about a box that you plug into your house. It's about a system. And I think that's where a lot of other people and manufacturers have fallen. So where I look at it is, I think of a heat pump as a heat source that provides efficient heat, or provides heat efficiently, and then how to achieve that. And when we look at heating systems, about 50% of the efficiency is the heat emitters, the radiators, the underfloor, whatever that might be. And the other half is the box sitting outside or in the garage, wherever that might be. So what I did was a whole system approach, looking at how does it interact with it. And I think that's where probably the key is done. So I look at not just how to make the energy efficiency, which is still very important. I control the speed of the pumps. A lot of manufacturers, well, most of them, maybe they're changing now, but back in the day, when you got your product tested, you sent it off the lab and they would adjust the flow rates and the speeds, and it was all fantastic. You got these fabulous efficiency figures, but in reality, nobody sold their heat pumps with a circulating pump integral. Installers would fit these things full speed. Therefore, you can never achieve the efficiencies in the lab. So what we did was an integrated approach. Everything that you need to make the system efficient, we include and have pretty much everything that I sell or supply, I have designed and manufactured and built in-house, with the exception of the hot water tank, which I merely designed that. It's made locally for. So everything I have has been designed by myself to work together, including boards, circuits, firmware, the whole software, the whole lot. And it has to be done like that to make it efficient, that nothing really off the shelf. So it's a whole system approach. And what we do is, when there's a heat demand and whatever this temperature is, 40 degrees, for example, the heat pump ramps up to achieve that. We adjust the circulating pumps to get this. You hear about this thing called delta T. This is the difference between the flow and the return temperatures from your radiators, whatever it is. This is 5. We adjust the speed of the pump to achieve that. As the water starts to warm up, the pump will run slower. The water comes back at the right temperature. When it starts to get too hot, the heat pump will modulate down. And the whole thing is constantly, every second, frigging all this thing out. And then what we find back in the day, even most other systems, when they distribute the heat to the home, and without getting too technical, you might have upstairs, downstairs, and a hot water circuit. They'll put those in the same thing and maybe use a diverter valve to switch the heat from the hot water to heating and vis-a-vis, but you can't guarantee the flow rate. So what we have done as part of us, we have a nice little sort of manifold system with all networks, very simple to install, very simple to program. And we might have a circuit for upstairs, one for down, one for hot water, and then we can adjust the speed of those to constantly dynamically balancing. So you may have, say, 3 or 4 radiators upstairs and maybe 10 down. This system will in real time adjust the heat demand where it needs to go. So that's what we do. And I wanted to remove the human intervention as much as possible. So if we can control the distribution of heat, it's almost self-commissioning, dare I say it. I don't like to use that word, but you have to get the air out of it and make sure the pipes don't leak. But from an efficiency-wise, I wanted to install efficiently as close as possible to lab efficiency. And by the by, I think I've pretty much done that. Maybe not exactly what's under the bonnet, but it gives you an idea of what I was trying to achieve, that sort of holistic approach in the system.
It sounds really fascinating because it sounds like you've really approached it at you've looked at every single part of the heat pump. And it's so interesting that you've done that. And I think that when I speak to people that kind of approach things in that way, they just have such a passion for what they do.
Yeah.
What sparked this passion for heat pumps, and why do you feel so strongly that heat pumps are the way forward for heating homes in the UK?
Well, if I give you a little bit of my background, it might give you an insight. Started life out as a civil engineer of all things, so building bridges and whatnot. I started out doing that. Then I moved into a bit of fluid mechanics, and then laterally, probably the last sort of 12, 13 years, I worked for a larger OEM boiler manufacturer, oil. The dirty word is to say. So I was their technical director. And maybe heat pumps is atoning for those sins over the years to try and make amends, but so that's sort of where we're at. And I'd have been involved in designing oil condensing, gas condensing, stainless steel hot water tanks, wood pellet boilers, ground source heat pumps from blank sheet of paper, cradle to the grave, and hopefully not the grave, but cradle to somebody's home. And so it gave us a great experience in that. I looked at heat pumps and I said to myself, what's the next big thing? We looked at biomass, and the concerns with that is high maintenance, like small children. They need lots of care and attention, and shovel it in and shovel it out. And if they don't give them the attention, they break down frequently. And that's biomass boilers. And I've built them, I've designed them, I've installed them, and I wouldn't have one. Okay, so not to put them down, there's a place for everything, but that market has moved on very quickly, and it's down to convenience. People are much push button technology. So you look at gas and you look at oil or whatever it is, you switch it on, comes on the clock, and it's fine. And what's the equivalent of that is the heat pump. It's green. I believe it's fantastic technology. So if I look at, how you can optimize efficiency, you can take a little bit of electric and get 3 or 4 or 5 kilowatts of heat out. They're very low maintenance. No matter what people will say, there's very little maintenance involved in them. And the holy grail will be is if you have green energy, they're a fantastic way of utilizing that. So if the production of energy is green or carbon neutral, by default, a heat pump is that also. And the infrastructure's in place. And yes, you may have to upgrade some of the things, but generally, I don't think it's a big issue, as people have said, because if you look at smaller domestic properties that might have an electric cooker or a 3 kilowatt electric immersion, a small heat pump to do those homes will only use 1 or 2 kilowatts in any case. So if it's a 5 or 6 kilowatt unit, and worst case scenario, 2.5 COP, you only need 2 kilowatts to run the thing. And, so I'm not as maybe pent up about people's, the grid won't take it, it'll not meet the demand. I'm a wee bit more, there's probably more happens when people switch stuff on at Coronation Street at 6 or 7 o'clock, whenever it's on with a cup of tea. So I'm not as concerned about that. But that's pretty much why I went into heat pumps. I looked at that. It's not just about heat pumps, it's renewable energy devices, hence the name. And it's looking at devices that utilize or consume or produce renewable energy. And that's why we sort of looked at that holistic approach. It's not just the box outside. And I do think there's a lot more to be done in integration with other systems and proper smart technologies, whether that's cars or batteries or things, and a heat pump would lend itself very well to that ecosystem.
So when we put a heat pump in 3 years ago, we didn't know anybody personally that had one. We didn't have any friends or family that had one. When we mentioned it to friends and family, they kind of said, what is that?
You're mad, yeah, or what is it? Yeah,
just blank faces.
Most people hadn't even heard of what a heat pump was. They kind of maybe heard of biomass, but not too many people in the cities had heard of heat pumps. It was kind of more maybe if you met somebody rurally who had something like a biomass that kind of knew. Obviously, there has just been such an enormous wave of interest through the media in this year. How has that exposure now changed your business, and how are you kind of looking to expand or meet the demand?
Yeah, no, very much so. Heat pumps have been very much pressed into the sort of public eye this last, no later than Monday there. It's sort of, it's on about inflating the whole thing. And yes, we have been aware in the background of things moving, and obviously have been. it's probably been a long time coming. We started this company about 7 years ago now, or 8 years in April. And, it's been a long time getting there. And yes, it's going to be this year. It's going to take off, and it's always tomorrow. But eventually, it's now happening. The government have thrown their weight into it. And yes, people will say, well, it's only £5,000. It's only this, it's only that. Really, what the government done, they've given the green light to heat pumps as the way forward, and basically invest, guys, get the price down, and there's going to be a market for you. We're going to support this transition. And I think, that's more important than what the money is, because some of these guys, the mother of invention is necessity. And I think ultimately the price will be driven down and volume is king. So a small gas boiler guy is 100,000 pieces a year, and a big heat pump guy is 10,000 pieces a year. So, and with that comes economies of scale, buying power, streamline automated production, and all of that. So we have been currently working on our next generation products, which is to, in essence, higher temperatures, lower cost, even easier to install. And if you look at the problems that need solved, it's not just the heat pumps. If you look at a property, what is the issues there? It's upgrading the system. Can you avoid doing that? You would have done it to look after defrost, if you can do something with that. And then there's a cost as well. And the heat pump is probably the cheap bit. It's the bit to install it, it's the expensive piece. And if you can bridge that gap by designing or change the technology that minimizes the remedial works that have to be done on the property, I think that's where ultimately the future will go. But certainly ourselves, we're working on higher temperatures, circa 75 flow temp efficiently. Yes, it won't be as good as something at 40 degrees, but it's not catastrophic. I'd still like to think at 65, we'll still have a COP of 3. That to me would then allow you to work with existing hot water tanks, existing pipes, existing radiators. And yes, one could argue, well, it would be so much more efficient at 40 degrees. Yes, but run it at 60 and save £5,000 off the installation costs. I would get that open to the masses sooner. And if the electric being produced is green, what difference does it make? So I think there will be a transition, the existing housing stock, to get over this hurdle, which is our emissions. I think heat pumps have a rein to play, and I think there's a transition between the new build, which yes, should be super duper efficient, low flow temperatures, all of that. But I do believe the higher temperature stuff will be ideal for retrofits in existing properties. And if you look at the housing stock in GB, was it 15 million homes, is circa 900 square feet, or 90 meters squared sort of size. And that's where the smaller heat pump, higher temperature will have a big impact. And if you can do that very cheap, very cost effectively, I think you'll see adaptation of these things at a much, much greater scale that's ever been possible before. And that's sort of the things that we're working on to trying to achieve.
So the government says that they want to install 600. We've heard that 600,000 is the minimum. Yep. We've actually heard that number go up to 1 million per year. Are you at Red ramping up your production? Is that something that you're?
Yeah, well,
what is your current production?
We're a few thousand, so we're very small in the scheme of things. It's back to sort of where the products are, what you can do and what you can't. And if I look back in the day, our product was designed at much more manual processes and certain machinery, but now there's hope there. It's easier to get investment these days, capital-wise, to sort of buy equipment and tools, because the market's there. Through no fault of my own, my market is going to grow 20-fold over the next 4 or 5 years, and it's a fantastic position to be in. So that then gives you the confidence to people either to lend, to buy equipment, machinery, automate a lot, and to reduce the cost. And I think that's the journey that most manufacturers will be on now. Some of them have started that, some will start it, but that's where, it's very hard to invest and get the price down and all that there, and then there's no market for these things. But I say that green light will drive investment, and whatever the government tip into it will be a drop in the ocean to what private companies will do, investment houses or individual companies. So I think that will ultimately make an impact. But if you were to design a gas boiler in the morning, you wouldn't be selling them out the door at £1,000, whatever they are. They'll probably be several thousand. I don't know if heat pumps will ever get down to those sort of prices, but they'll come down significantly from where they are today, and that's down to volume.
So you mentioned at the outset this holistic approach to the way that RED actually does a system. So there's a complete design with a specific property in mind. Now, is it possible to take just your heat pump into an existing house? So let's say we've got an air source heat pump. We just want to remove ours and plonk a RED unit in. Will that work, or does it require more to actually tweak some of the other bits and pieces around that to make it run as efficiently as you intended it to?
Yes, it's a two-way street. Yes, we could just take it out and plunk it in because we can run at higher temperatures and control the flow inside, and we can do that. Or it may be worthwhile for a small amount extra put on with a distribution or manifold system that it might be better to zone the house a wee bit more. So, and that would be a trade-off between what you're willing to pay over potential efficiency gains, and but having that higher temperature of 65 flow is opens up a lot of doors. Let's put it that way. And then what we can do, depending on the size of the property, we can link two or more together intelligently. So rather than just plug them in and hope they all work, we actually control them and depend on demand and we need to ramp them up or ramp them down, whatever it is, so that sort of thing. So the short answer is yes, but to optimize the efficiency, you might do a little bit more. But you see, and this is probably part of the problem where heat pumps are at the minute. And what we'd like to solve is to, looking at our next generation products, is to close that gap that there'd be even less. My ideal dream, coming from here in Northern Ireland and the south of Ireland, where oil is upwards of 70% of the heating in people's homes, and they're quite crudely done, is I have a dream where I can literally snip the two pipes, plunk the box outside, plug it in, put the power in, switch it on, and hey presto, job done. And that's really what I'm working on at the minute. And I think if we can achieve that certainly for rural properties, they need a large output that'll transform those. And then we're also working on a smaller product for the mass market, this sort of 90 meter squared property. So short answer is yes, Mars. Long answers, if you want to optimize it, you have a little bit more to spend, but that's a trade-off between return on investment versus upfront capital cost.
So is my interpretation correct? Am I picking up the right things? You're saying that the RED heat pumps run at higher temperatures. With the conversation about heat pumps at the moment is very much the hang up on insulation, that because heat pumps run at lower temperatures, there is this massive concern about that home having the right insulation in order to contain the lower temperature heat that it's producing. With RED, you're kind of negating a lot of those insulation concerns.
Up to a point, there's sort of two train of thoughts, and if I can sort of maybe recap that. So yes, in an ideal world, a compressor compresses gas, and if you compress the gas at a lower pressure, you need less electricity to do that. At a lower pressure, you get a lower temperature. Simple. Well, maybe not. But so if I then want higher pressure and higher temperatures, I have to run the compressor and use more electric to achieve that. Now, depending what refrigerants you use, you can get those higher temperatures quite efficiently. Not as good as the low temperatures, but still not that bad. So, but then there's a trade-off between insulating your home, upsiding the radiators, changing the pipework, and putting in this sort of 40 degrees temperature heat pump, which runs very efficiently and everything's fine, but that's a huge capital cost. Or you can go down using different refrigerants that can run up to 70, 75 degrees, relatively not as efficiently as the 40 degree one, but it's not a total disaster. But then you save the £5,000-6,000 of capital investment. And that's where I believe there's a trade-off here between, going for super duper insulation and making a big impact on the carbon emissions. And I think it's almost like a hybrid car. There's a transition here until the whole housing stock and car stocks is purged. I think ultimately the best way is to insulate and use less energy. However, not everyone's going to be able to afford that. And if we can do something which is still an efficient system, maybe not as cheap to run as the 40 degree one, but maybe only 20% more, but then you don't have the high-end capital costs and disruption. And I've just decorated my home last month and now you want me to rip it out, and nobody wants to do that. And these are all real life factors. And if we can mitigate that, I think that will have the biggest impact over the next sort of 5 to 10 years. And then as things progress, things will move on. So there's two schools of thoughts. I'm probably more in the high temperature one, purely because I know it's possible. But both have their merits. But I think to make the biggest impact, the higher temperature will have is the way to go personally.
Another conversation that's being had a lot at the moment in the public domain is what does a heat pump look like? What is it going to look like out? Because it's such a different beast with regards to people are so used to having their boilers inside their house and then hiding them into utility cupboards. Heat pumps are outside, and what is so noticeable straight off the bat is that the red heat pump does not look like any other heat pump I've ever seen. Why have you made it the round shape, and why has it got the plastic cover as opposed to metal case?
Well, it's a question of form follows function, and it was done in such a way to maximize efficiency. And it's if I roll back the clock again, so who are most of the manufacturers of heat pumps? They're mostly Asian manufacturers in the Far East, and they're all aircon and they're all air conditioning. So they've got the tools, the big presses to stamp out the casings, to build evaporators. So, there's a bit of market for heat pumps. Let's get involved in that. So they've got economies of scale. They pump out millions of these things in that part of the world. So then they just change the pipework a bit inside, reversible. Let's use the box that we have, and the beige box, out it goes. And it's all right. It'll do the job. They'll argue differently. I went from a different approach. I said, well, how would I optimize the efficiency? How would I make my thing efficient? Hence, it's round, so it's symmetrical airflow. And heat pumps, you get the heat from the air, so you want the air, so you want it symmetrical. So we've got dead spots. If you put a round fan in a square shape, why put a round peg in a square hole? That's what you're doing. So you get dead spots. So it kind of makes sense. I make the thing round. I put the fan on the top. It draws the air in. It puts the noise and the exhaust air out to the top. And at Symmetry, we've done a bit of, I'm going to say CFD, but it's computational fluid dynamics. So we have optimized the airflow and refrigeration flow to make sure there's no dead zones in this evaporator or the heat exchanger. So we've done that. Plastic casings, why is plastic? They don't rust, funny little thing. And if we live in an island here, coastal areas and things like that, so you're immune to that. And also it gives us a chance to sort of modify the shape for, again, the airflow and efficiency and whatnot. So it was very much a case of form follows function, and rather than we didn't design it and then put the bits inside. It was very much let's make it, and then how do we make it look, dress it up a bit, as I say. So, well, I like it, but I'm biased. Others don't.
So do I.
Very cool. So in terms of the actual design, because it's very difficult to see on the photos, but the evaporator, does that also run completely circular?
It's a tube, yes. So it's about 300 degrees ball evaporator, and then there's a little bit at the back where the tubes and the distributors and the refrigerant pipework lies. So, but it's about roughly 300 degrees all evaporator. All around, all a heat exchanger, fin and tube heat exchanger. So wee bit more expensive to make, but the trade-offs, the efficiency, and again, when we started out in this, it was to try and make it as efficient one as we could. And because I couldn't compete with all the large global PLCs out there that make heat pumps. We're relatively a small company, and what we had to do was to make it efficient and to put in features and benefits that people would maybe recognize as worthwhile and sell it on that behalf, rather than, because otherwise it'd be a Me Too box, and Me Too equals, are you cheaper than them? If not, you're not going to sell any. So we try to do it a wee bit different. I think that's what we've achieved. So that's sort of why it is the shape that it is, and it wasn't some sort of design feature. And then I'll add one little thing in that. Why is it that the heat exchanger only at the top and not at the bottom? So it's about 600 mils or 2 feet in old money off the ground. And you think this autumnal time of year, if you're out in the rural area, the leaves blowing around, and where are they going to end up when you've got a big fan sucking away? Guess what? Up against the back of it. So we lift it off the ground a little bit. Again, drifting snow, you will get a bit of that as well. So again, where does it end up? In there too. And little things like that. And then we would have, there's an integral drip drain that you can't see it, but the drain's down internally. So a heat pump, when you extract heat from there, you cool it, bit like a glass or something with cold liquid and condensation on it, you'll get up to 1 to 2 liters per hour to this thing. And where does it end up? On your ground. But we put it to drain, and you might say, well, what difference make it? It'll soak away. But in the winter time when you have frost, this water drains out, and then you've got a skating rink, which you don't particularly want as well. So there's all little things that don't become immediately apparent, but even I'm sort of trying to remember what I've done back in the day. So it's just trying to think of what we've done over the years, but little things like that. And these are little features that you add on by default, and that's how we try to achieve it.
So when we had installers or people that actually came to quote us for our air source heat pump, everybody said we needed a buffer tank. I think I read that your system actually doesn't need a buffer tank. Why is that?
It's down to modulation, i.e. the maximum and minimum output. And, some of the older different heat pumps, again, the compressors may or may not be heat pump optimized. They may be from a refrigeration background. They might only have like a 4-to-1 or a 3-to-1 turn down ratio. So if it's 10 kilowatts peak, it might only be fit to go down to 4 or 3 or something like that. We would have up to a 7-to-1 turn down ratio. So our 10 kilowatt can go down to about 1.25 kilowatts, which really is quite low. And heat pumps, the bottom end is probably more important than the top end. So you can run longer without stopping and starting. So the fact we can modulate down so low, and also we don't then need this buffer to dump the heat into. The other issue that you would have had is the defrost cycle, which is very critical to heat pumps. And that's the predominant reason for these buffers, because people cannot guarantee, if somebody, the radiators close off, the heating system off, the heat pump's in defrost mode, it'll freeze up and split heat exchangers and all. So we have got quite clever logic inside that will prevent that happening. We can monitor, we measure the flow as opposed to a switch. We actually physically measure the liters per minute going past. We measure the temperatures. We know the speed. Again, because we can control the pumps and the circuits. In defrost, we just speed up the pumps a little bit to guarantee the heat coming back. So therefore, we know we have the right flow rate, we have the right temperatures. And if the wheels come off, we then stop it before we would destroy the heat pump. That's the reason why we don't. And if I then look back, it's probably from the horror stories, and was it 2010, the big hard frost and heat pumps dropped like flies. And a lot of that would have been down to the logic not being in there to control the defrost, and it froze up outside. Well, truth be told is the heat pump killed itself because the water came back too cold and froze inside it, as opposed to the frost got it outside. So there's a lot of these things that go on that it doesn't become apparent. So the best way is, let's stick a buffer in, or let's put glycol in the circuit, rather than actually designing the problem out of it. These were things to mask the symptoms as opposed to fix it. So that's why we don't use buffers, and we don't really need them. Only one caveat, of course, but if you have multiple heat pumps together, so once we go beyond 2, we probably will have a small buffer, because but then it's a different animal. That's more sort of a commercial application, but we can link up to 2 heat pumps together and control them that way without a buffer. All right.
There's a fascinating amount of attention to detail in the design of the red heat pumps. I
don't sleep at night, no.
What is the thought process, though, with regards to decommissioning a heat pump and then disposing of that heat pump when it comes to red heat pumps?
Yeah, well, hopefully you have a long and happy life with it, and that's minimal. But it's like all those things, decommissioning or swapping them out. Ultimately, we can take them back, recycle them. But the best way is you'd have to, before you transport these things, we recommend you probably extract the refrigerant out of it, and then once you have that, it then becomes something that can be recycled quite easily. You have electronics and that, which will have value. There's a lot of copper, which is quite valuable as well. So look, the plastic is recyclable, the copper is eminently recyclable, and then you have a little bit of the metal framework inside. So if you're doing it, that generally you would degas them on site and recover the refrigerant to dispose of it. You'd need an F-gas engineer for that. Relatively straightforward then after that. It could be like other fridge freezers where they have only a very small charge, and they're sort of taken down to your local recipial or a local recycling yard, and that sort of way. So I think it's quite a straightforward process, and maybe that's something for the future. It's all easy now. There's lots of heat pumps only going in what happens in 10, 15, 20 years' time. And I think that's something that we are sort of not concerned, but think of as well, and how to make it more recyclable, the whole thing.
So which refrigerants are you currently using in the existing line of red heat pumps? And is the switch going to be to propane for your high temperature ones?
Yep, absolutely. So we're in the process of sort of moving or transitioning towards away from R410A, and that's just, we had that sort of back in the day, and we're moving towards propane over the next sort of short term, months as opposed to years. And again, with sort of two stages, we're putting the new internals in our existing body, and then we have the next generation, which will be new internals and a new body, and that will sort of cover those sort of the smaller outputs and the more sort of true retrofittable version. So yes, R290 or propane, R290 for its technical term, and again, it's a global warming potential of nominally 3. And yes, there's maybe concerns people say about propane, and is it any worse? Yes, there's maybe a lot of mains gas there, but in Northern Ireland we would use bottle gas for cookers and things like that. So you've got a 13 kilogram bottle of LPG and a rubber hose attached to it. I think a heat pump holding a kilo of propane in a high strength pressure tested enclosure is not the big risk people that maybe will make these things out to be. So I'd be fairly, and also the refrigerant charge is significantly less. It's maybe upwards of a kilo just, and it's outside. It's efficient. You get high temperatures out of it. And it's a natural refrigerant, and I think it's certainly the way we're going anyway. There's other alternatives, but I think it's the one that ticks all the boxes with regards to performance, efficiency, and the environment.
So am I correct in stating that Red currently has a 10 and a 16 kilowatt heat pump?
Yeah, the two models.
And why is it that you chose those specific sizes?
Yeah, well, it's probably down to the market. Could I compete with the 5 and 6 kilowatt units in the very price-driven market? No. So we went for the larger, and I'll probably look at it. Our products are probably more suitable for the larger, either new build type product or sort of larger retrofit, where you need the high temperature, you need the performance, and you need the system that works together. And that's where it's, wouldn't say it's competitive. That's maybe not the right word. It's more sort of focused on performance and efficiency and that side of things, as opposed to I'm going to buy 200 of these off you, Jason. What's your best price? And we're not there yet, or weren't there when we started this company in those days. So we had to pick where we went to. So, and that's the two models that covers most of that sort of rural, larger properties, and they'll do the vast majority of it. But the next range that we're coming on within the year, it'll be 5, 10, and 15. And again, that will be more sort of the higher volume, using that technology we have and making it accessible in a smaller, more efficient or package, not so much efficient product, but taking the lessons we've learned and condensing that technology and that sort of thing. So that's where we are today. That's why we have the models, but that's where the roadmap is for the future.
So you mentioned that the government has said that they're going to announce this £5,000 grant, and as you said, at least it's a starting point. What is it? How is it in relation to purchasing a Red unit at the moment? How much of a contribution would it be to that homeowner?
Yes, it's a good chunk of the heat pump, don't get me wrong. And the heat pump is still the cheap bit. It's the installation's the problem. And by the time you get a heat pump installed, depending where you are in the world and what you have to do, it can range from £5,000 to £15,000, these things. And that's purely because if it's a new build, if I take new build, it's easier. So if I was putting a heat pump into a new build home, maybe a larger property, underfloor heating, 2-3 bedrooms, 250, 300 meters squared, it's maybe a couple of thousand or £3,000 extra over an equivalent fossil fuel system. So you look at that because you're buying everything anyway. That's the sort of order of magnitude. Now you don't get the grant for that because it's a new build. So from that perspective, you're doing it all anyway. When you come to retrofit, it's a less clear-cut case because of all, you have potentially a fully functioning system and you're just going to throw this money at it. And you then will have a fully functioning system that just happens to have a heat pump in it. So it's a harder decision to make. And what this money is with the government is to assist that, take away some of that capital cost. You should then have a lower running cost. And I think there's a little bit of a green investment from the homeowner as well, sort of helping that journey. And it will make a good chunk of it. I think where I see it is with the next generation products is to close that gap between the cost of the install and the cost of the product. If I can mitigate a lot of those changes that has to happen to make the heat pump run efficiently, and to sort of use technology to solve those problems with regards to defrost and high temperature and flow rates and things like that, I think that will go a long way to making the install cost cheaper, because the heat pump is probably a third to 40% of the cost of a system.
Can any MCS-accredited installer install a RED heat pump?
Pretty much. We would offer a bit of training. So again, whilst we try to minimise the wiring and the connections and the plumbing, we'd be keen that we do a bit of training. There's no issue with that at all. So they bring them here, or with places we're in Northern Ireland, but we've people there work with us in GB as well. So and we're happy to do that. And maybe the first few installs, a bit of hand holding. Certainly from a design point of view, we can do that as well, and give a few pointers. So generally, yes, we're MCS accredited, the product, and we're willing to work with anyone that's is also MCS accredited and install these things. So yeah, short answer is yes.
Is the Red Design services available throughout the UK for all homeowners?
Yes, it would be. So again, with other partners that we work with that sort of design them to our specification, and so we would here in Ireland, north and south, in GB, with people sort of that will do it. It's all very straightforward because, as I say, it's all network, it's all controlled. You put in the 2 or 3 blocks, it kind of looks after itself. All you're really doing is a bit of a sanity check that the radiators are fit for purpose, or if it's underfloor and it's a new build, that it's designed correctly, and there's a bit of a match up between heat input and heat output. So it is relatively straightforward. We try to simplify these things. You may have to upgrade your hot water tank because again the coil might be sufficient and things like that, but that's very much site specific. And that's why we work with installers to do a wee bit of a pre-installation survey. You just don't turn up in the day and your van, your box of bits. So it's very much a question of figuring out what you need to do and what you don't need to do.
When we recently spoke to the head of the Heat Pump Association, he was saying that they're really pushing to the government to start to see some legislation come out to start getting heat pumps into new builds and get property developers to put heat pumps into new builds. What's Red's thought on that? Do you think that would push the market a little bit too fast, too quickly?
No, I don't know. I think you do need legislation, and yes, there's talk of by 2025 fossil fuel boilers to be banned. And yes, the headline's gas, but it's all fossil fuel, and that will help. Because ultimately, some builders are greener condensing solar, but if you're not building a home for yourself, it's going to third party. Profitability comes into play here, so it's a bit of carrot and stick. If you don't have to do something, why would I want to do it and give away a few £1,000s when I could have it? And it's a two-way thing. So I think consumers that are buying these properties, they should maybe pick more focus put on the energy efficiency rating of them. Is it an A-rated home or a B-rated home? And yes, it's got a heat pump, which is great, and the bill is going to be lower and it's easier to run and it's better in the environment. And it's a wee bit of that. So it's not just a question of the car or the stick. I think awareness that homeowners maybe say, "Oh, I love this house," but nobody thinks, "Fantastic, I've got a heat pump system." It's the kitchen or the bathroom or the garden that they're after. And it's maybe educating people that yes, if you have this thing, it'll be significantly cheaper to run. It's no CO2 emissions and that. So I think it's not just a question of let's get the legislation in here. I think if you have willing participants, it's much better than pressing people. And I think if you can have people to want to do this and desire to do it, that market will drive it. I think that's more important than beating people into submission. They might resent it then,
Brilliant. Well, thank you so much, Jason. It's been such a pleasure speaking to you. I think that you guys have got some really innovative, exciting things in the pipeline. I can't wait to see what new heat pumps come out. Yeah.
It's a bit like Mars, the red planet, but hopefully we'll turn the planet red as well. So
Quite right.
Yeah.
Well, thanks very much, Jason. It was a pleasure speaking to you,
Thanks
and
for your
hope to
time.
speak to you again soon.
Yeah, super duper. All right, folks. Bye now.